Okay, so hello everyone and welcome to the OneClass channel. My name is Donna Riel and I'm a recent master's graduate from the Material Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or tutoring, then check out the links in the description below. So now let's just get started on our set of questions for today's session. So the text is very big, but just asks, what is a half reaction? Why must the number of electrons lost in the oxidation half reaction equal the number of electrons gained in the reduction half reaction? Summarize briefly the steps in the half reaction method for balancing redox reactions. And also, what two items must be balanced in any redox reaction or in any reaction? So this is like a multi-step kind of question. But basically, a half reaction can be either an oxidation reaction or reduction. Okay, so they also show the transfer of electrons from one atom to another. So just to answer the second part of the question, why must the number of electrons lost in the oxidation must equal the number of electrons gained? So electrons lost is equal to electrons gained. And this is just because of the law of conservation of mass. So the conservation of mass just states that because matter cannot be destroyed or created, like if you had one electrons leaving, they need to go somewhere. So that's why you need the same number lost is equal to the same number gained. Okay, so the next part of the question just asks to summarize briefly the steps in the half reaction method for balancing redox reactions. And I'll pretty much just answer the next question, what two items must be balanced? Basically, your atoms must be balanced, and also you want to make sure the charges are balanced as well. So I'll just add those as part of the steps. So let's say we had an example. I'll write the example first. So let's say we had an example of an unbalanced reaction. Plus iodine or iodide makes xenon plus I2. So this is what a typical unbalanced redox reaction might look like. So the first part of solving a question like this is just to write reduction and oxidation half reactions. And also in this same step, we want to make sure that to balance the atoms as well. Okay, so the reduction reaction would be this xenon so you can see it goes from an oxidation number of like -6 because each oxygen has a -2 charge and there's 3 of them. Sorry, it goes from +6 to 0. So because its oxidation number was decreased, this is what got reduced. So I want to now balance the atoms. So you'll see that there are 3 oxygens on the reactant side and there are none on the product side. So in aqueous solutions, to add oxygen, I am going to add 3 H2O. Okay, so notice that now I have 6 hydrogens and 3 oxygens on my product side, so I'm going to balance out the hydrogens by adding 6 H plus to my reactant side. So now all the atoms should be balanced, and I can write down my oxidation reaction, which is the negatively charged iodine to I2. And all we need to balance here is we just need to put a coefficient of 2 to make everything balanced. Okay, so step 2 would be to balance the charges. So we do this by adding electrons. So if we look at our reduction reaction, you'll see that there are 6 positively charged protons on our reactant side, and on our product side, everything is neutral. So to neutralize these protons, then I need to add 6 electrons to my reactant side. And my product side just stays the same. For my oxidation reaction, I have 2 negatively charged ions. So to this side, I just need to add 2 electrons to balance out those charges. So what's also important with redox reactions, like we mentioned earlier, is that the number of electrons lost must equal the electrons gained for both our oxidation and reduction reactions. So for our reduction reaction, you'll see there are 6 electrons. So I need to have 6 electrons on my oxidation reaction as well. So I need to just multiply this whole thing by 3. And we end up getting 6 I minus plus 3 I2 plus 6 electrons. Okay, so now we have our electrons balanced. So step 3 is just to combine overall redox. So first, let's write all of our reactants down first. So this should be 6. And now let's write down all of our products. Okay, so basically when you get to this step, you want to cancel out anything that is the same on both sides. So in our case, it would just be our 6 electrons canceling out on both sides. And we are left with our net redox reaction. So let's double check that everything is balanced. We have 1 xenon on both sides, 3 oxygens on both sides, 6 hydrogens, and 6 iodine. And in terms of the charges, we have 6 positively charged protons, 6 negatively charged protons to neutralize each other on that side, and everything is neutral on the product side. So this is an example of the steps that you would take in balancing redox reactions. Okay, so let's see what the junior tutor said. So a half reaction is an oxidation reduction redox reaction, which depicts the change in oxidation state of the atoms in the reaction. This change in oxidation state is brought about by the transfer of electrons from one atom to another. Oxidation reaction involves the loss of electrons, and its atom is called a reducing agent. Reduction reaction entails gain of electrons and functions as an oxidizing agent. An acronym can be used to easily remember main ideas in redox reactions. Okay, so I've never seen this one before, but they used LIORA, so lose electrons, oxidation, reduction agent, and GEORA, gain electrons, reduction, oxidizing agent. I personally use like LEOGR or oil rig, which is oxidation is losing and reduction is gaining electrons. But you can use any of these different acronyms. In balancing half reactions, it is imperative to balance the number of moles and electrons in a reaction to maintain the law of conservation of mass. A summary of steps for balancing reactions using redox is as follows. Step 1. Write the unbalanced ionic equations without the spectator ions. 2. Determine the half reactions, which atoms undergo oxidation and reduction. Step 3. Write the number of moles of the reaction that does not contain oxygen and or hydrogen, or balance the reactions containing oxygen by adding H2O. Then balance the number of hydrogen by adding H+. So this actually depends on whether or not your solution is in acidic or basic conditions. So when you're in acidic conditions, you would add H+. So this is your typical example, like a lot of examples are in acidic conditions, but just so that we are all aware, if we were in basic conditions, then we would just be adding OH- ions. But anyways, step 5, balance the charges for each side by adding electrons in the half reactions. Oh, here it is. So 6 for basic solutions, balance the reaction by adding OH minus in each side for every H plus ion. Then simplify by combining H plus and OH to form H2O. Yeah, so this is what you would do if you were in basic solution. Kind of adds like some extra steps. And they have an example of silver and zinc. Step 1, write the unbalanced ionic equation. So silver solid plus zinc 2 plus makes this silver oxide plus zinc solid. They identified the half reactions. So the zinc 2 plus got reduced because its oxidation number went from +2 to 0. And the silver got oxidized. It went from an oxidation number of 0 to +1. Step 3, no change for zinc, as there is a 1-to-1 mole ratio in the reactant and product side. Okay, so see the atoms are already balanced. 4, since there is 1 oxygen atom in the product side, add 1 mole of H2O in the reactant side. Then balance the number of hydrogen atoms by adding the corresponding number of H plus in the product side. Yep. And then step 5, balance the electrons lost/gained in the half reactions, then simplify. 6, add 1 mole of OH minus in the product and reactant side per 1 mole of H plus present in the equation to yield. So see here they added OH minus on both sides and H plus as well. Combine the OH and H plus to form H2O. So they pretty much just combined these two. And then simplify. Okay, so 2 zinc 2 plus, 2 OH minus. And everything is balanced in terms of the atoms. And also the charges. Yep, so this solution is correct.